This question comes from Zach, who asks, using an umbrella to stop the rain is pretty boring. But what if we used a laser that targeted and vaporized each raindrop before it could hit the ground? Stopping rain with a laser is one of those ideas that sound completely reasonable. But, okay, we are seriously talking about stopping rain with a laser now. The problem is, this isn't a very practical idea. First, let's look at how much energy we would need. Vaporizing a liter of water takes about 2.6 megajoules of energy. And if a rainstorm is dropping half an inch of rain per hour, then, interestingly, if you multiply these two numbers in a smart calculator like Wolfram Alpha or Google, you get a value in terms of power per square meter, which is exactly what we need. The calculator tells us that to protect each square meter with a laser, we would need about 9 kilowatts of power. 9 kilowatts per square meter is nearly 10 times the power Earth receives from the sun. And while that already sounds like a lot of energy, we also have to remember that water's ability to absorb energy is incredible. Heating water to its boiling point only takes about 10% of the total energy. Turning it from liquid to gas takes the remaining 90%. In the end, we'd be filling the air with tons of hot steam, essentially turning the environment into a human-sized autoclave. And if you didn't know, autoclaves aren't exactly the most comfortable places to live. But it gets worse. Vaporizing a raindrop with a laser isn't as simple as it sounds. There have been many studies on this topic, and the general conclusion is that if you don't vaporize the droplet instantly, the laser will just break it apart into smaller droplets. If you zap a water droplet with a laser, it usually just explodes into a mist rather than completely vaporizing. So, to fully vaporize a raindrop, we'd likely need even more energy than the already unreasonable amount we calculated earlier. Then there's the problem of targeting. Research suggests that, in theory, this could be solved perhaps even without military-grade equipment. High-speed cameras can track the 3D position of a baseball or football hundreds of times per second to help referees make calls. A similar but more advanced system could track incoming raindrops. For targeting, adaptive optics allow for extremely fast and precise control of light beams. Covering a 1 square meter area would require something like 500 direct pulses per second. This is slow enough that relativity wouldn't be an issue, but the device would, at a minimum, need to be far more complex than just a laser pointer on a swiveling base. What if we skipped targeting altogether and just fired lasers randomly? If you fire a laser beam in a random direction, how far will it go before it hits a raindrop? This is actually an easy question. It's the same as asking how far you can see in the rain. The answer is at least several hundred meters. Unless you're trying to protect an entire neighborhood, firing powerful lasers in random directions probably won't help. And honestly, if you are trying to protect an entire neighborhood, firing powerful lasers in random directions definitely won't help.